Two quadratics multiplied, and we're asked to find the minimum value. So it feels like the best course of action is to multiply this out, especially because one of them has a minus 4x and one of them has a plus 4x. It's going to lead to some cancelling down. So let's do this. Just like carefully multiply the terms out, x to the 4, so on. And then same down here. You can even start cancelling out as you go along, or wait until the end. Okay, so it becomes x to the 4. I've got 6. It's going to be minus 10x squared plus 9. Right, this is actually, although it's a quartic function, it's actually looking a lot nicer than that original set of brackets. Okay, two methods now for dealing with this. First method is actually like there's two methods for finding minimums essentially. One is differentiation, which you may or may not have yet covered, and I will talk about that briefly. And the second method is completing the square. Now, in theory, you've covered completing the square for quadratics. This is going to work in exactly the same because this is actually known as a hidden quadratic. It's just a quadratic in x squared, essentially. So just, you could even do a substitution and let y equal x squared, and then it would become y squared minus 10y plus 9. So complete the square on that and then replace y back by x squared at the end if you want. I'm going to go through it directly and complete the square in terms of x squared. So I have the minus 10 to give me 5. That is going to give me x to the 4 minus 10x squared plus 25. So I need to minus 25. And I'm nearly there. Remember, the great thing about completing the square, as well as like deriving the quadratic formula from it, is you can get the minimum quite quickly. This thing here is always going to be greater or equal to 0. It can't ever be negative. So the smallest value that it can take is 0. And that when it is 0, you'll get a minimum minus 16a. Okay, really nice. I like the, completing the square aspect, but for a hidden quadratic. Right, if you have covered differentiation, maybe a second year A level, for example, then, it will work. It will work quite quickly, in fact. So find the first derivative, bring the power down, lower the power. I'm not going to talk anymore about why we're doing that. Set it equal to 0 for stationary points. Factorize out as much as possible. So 4x and then x squared minus 5. Yeah, it's not as good, this method, I don't think. So x is going to equal 0. Oh, sorry, I messed that up. Should just be a 5 there. X equals 0 or plus or minus root 5. Yeah, this method is not as good because we're going to have to now substitute back in to find the minimum. Although we can put it back into here. So I'm going to get y equals 9 from here. And then root 5 and minus root 5 are actually going to give me the same answer. So when I put root 5 into here, I'm going to square it to give me 5. Square it again is going to give me 25. Then I'm going to minus, so 5 minus 50 here, because root 5 squared is 5, so minus 50 plus 9. So we're going to get 9 minus 25, which again gives minus 16. Okay, it's not bad. Not bad, actually. Just don't put it back into the original one. Put it back into this quartic. So in that case, we get the answer of minus 16 as well. I think the question intends you to complete the square, but, differentiation is there to help as well.